Alright, we're taking a look at 423. How can I solve it? We're going to solve exponential and logarithmic equations. And number 67, taking a look. Eduardo thinks he can solve 6 to the x equals 20 in just one step. The solution is x equals log base 6 of 20. Is he correct? Explain why or why not. Well, from Algebra 2, we know that log base 6 of 20 equals x. So he's correct because he used the properties of logarithms correctly. Is it practical? Explain. Well, log base 6 of 20 is correct. Is it practical? No, because that's not a common log. I don't know anything like that. Really doesn't tell me any more than 6 to what power equals 20. It's basically, in my mind, about the same thing. I don't have a number that I can visualize with that. Anita says she knows how to solve 6 to the x equals 20 using logarithms in another way. She tells Eduardo to start by taking the log base 10 of both sides and then applying the power property of logarithms. Let's try Anita's method. So we've got 6 to the x equals 20. The log of both sides that Anita is talking about is just writing log here and log here. So she took the log of both sides and then applying the power property of logs. What does that mean? That means if I have a power inside a log, I can put it in front. So now I have x times the log of 6 equals the log of 20. So to get x by itself, I can just divide by the log of 6. So we've got x equals log of 20 over log of 6. Now, we've still calculated. Now, I can press this button in my calculator, the common log of 20 over the log of 6, and I can get a number. Plugging that in my calculator, I get the number 3.103. So 6 to the 3.103 equals 20. All right, that works. The last thing in number 67 is Eduardo's older brother, Emilio, who is taking calculus, looks at Eduardo's equation and says, just take the natural log of both sides. What does he mean? Well, if we wrote log of both sides, log base 10, can we take log base e of both sides? Is that the same thing? So the natural log of 6 to the x equals the natural log of 10, or no, equals the natural log of 6, 20. Power property puts the x here. Divide by the ln of 6, the natural log of 6. Can I press that button on my calculator? And yeah, I get 3.103. So we should have just discovered that the log of 20 divided by the log of 6 is the exact same thing as the natural log of 20 divided by the natural log of 6. 68 gives us a chance to practice kind of what we were just working on in 67. Begin by solving using a method of your choice. Estimate first. So 1.05 to what power is 2? My estimation would be, I don't know, bigger than 10. That seems like a good one, but not too big, I would guess. I am going to use, let's take the log of both sides. Log of 1.05 to the x equals log of 2. Power property puts the x in front. And then I can just divide x equals log of 2 divided by the log of 1.05. And that button I can press. 14.207. So Bigger than 10? Not bad. Alright, solve them using a method of your choice. B. 15 times 3 to the x equals negative 6. Alright, the first thing I'm looking at when I see this is one of our exponential functions. When is that going to be equal to negative 6? So we know, because we've graphed many exponential functions, that graph's going to look something like this. Now let's think about it ever equaling negative 6. Not possible. Its asymptote is 0, so it is always greater than 0. That'll never be a negative number. Let's look at the next one. This one, we have a negative 12 times 10 to the x plus 3 equals negative 3. So I've still got that equals negative 3, but I think something else is going on. If I subtract the 3, I'm equal to negative 6 again. But I've got this negative 12. So I'm going to subtract the 3, get negative 6. Divided by negative 12 is going to give me 10 to the x equals negative 6 over negative 12. 1/2. What kind of a number gives me 1/2? Well, I know that if it's negative 1, I get 1/10. If it's negative 2, I get 1/100th. So maybe negative, I don't know, negative 0.5? What's that going to give me? My estimation. Log base 10 of 1/2. That I can just plug in my calculator. And then I'll get negative 0.3. So I was actually not far off there. All right, let's keep going.